Hello. In the previous class, we have learned synopsis, many points from the chapter sets, relations, and functions. Today, I am going to do some shortcut method problems along with you on the board. This will really help you a lot. So, I will number the shortcut methods we will be doing. The first one, that is A. Suppose A and B are two finite sets. Or in short, I'm writing two sets. Then you want to know how many functions you can make from set A to set B. The number of functions formed, that will be equal to number of elements in the set B power number of elements in the set A. This is the formula. But whereas in B, if you are making function from A to A, then how many such functions can be formed? The number of functions formed can be written as number of elements in A power number of elements in A. For this, I will give you examples also so that you will understand better. Suppose A is the set having 1, 2, 3, and B is the set having A, B. If F is the mapping from A to B, then the number of functions you can make over here as per the formula, number of elements in B power number of elements in A. Number of elements in B is 2. Number of elements in A is 3. So total 8 such functions can be formed. But if you have a set B first with A comma B and then set A 1 comma 2 comma 3, then if you want to find how many functions can be formed when you are taking the function mapping from B to A, so that will be number of elements in A power number of elements in B. Number of elements in A is 3. Number of elements in B is 2. So 3 square, you can form 9 such functions. The next example I'm going to give on the side is, suppose you are taking the set A, 1, 2, 3, and the set B, A, B, C. You are making the function from A to B. So here, number of functions which you can make is number of elements in the set B power number of elements in the set A. Number of elements in the set B is 3. Number of elements in the set A is also 3. So total 27 functions can be formed here. So this is the first shortcut method. So in that way, we will learn many more shortcut formulas. The second one is A and B are two sets. We are making function from a finite set A to a finite set B. Now, we are finding how many 1 functions can be formed. Not just functions. How many 1 functions can be formed? That will be number of elements in the set B, P, number of elements in the set A. It is permutation. But the condition is number of elements in set B should be greater than or equal to number of elements in the set E. So let us take examples in this case also where we are dealing with permutations. For example, I am taking A equal to 1, 2, 3 and B is P, Q. So we are making number of 1, 1 functions from A to B. We have to see number of 1, 1 functions. But the problem is number of elements in the set B is 2. Number of elements in the set A is 3. We can't say that 2 is greater than or equal to 3. That means we cannot form 1, 1 functions at all. 0. No 1, 1 functions can be formed. Let me give you another example. Suppose A is the set P, Q and B is the set 1, 2, 3. So in this case, we have to find how many 1, 1 functions can be formed. That will be number of elements in the set B, P, number of elements in the set A. Number of elements in the set B is 3, P, number of elements in the set A is 2. 3P2. And 3P2 is start with 3, take 2 numbers. So 3 into 2, that is 6 number of 1, 1 functions can be formed. Suppose if we have set A as PQR and set B as 1, 2, 3. Then in such case, number of 1, 1 functions formed can be taken as same formula, number of elements in set B, P, number of elements in set A. Number of elements in set B is 3, P, number of elements in set A is 3. 3P3, it is 3 factorial and 3 factorial means 3 into 2 into 1, that is 6. So here also 6 1, 1 functions can be formed. Let's go to the next shortcut formula, that is the third one. If F is the mapping from A to B, then if number of elements in the set A is n and number of elements in the set B is 2, you can find how many onto functions can be formed. For that, the formula is 2 power n minus 2. Here also we can take example and show. So in the example, I will take A as 1, 2, 3 and the set B as P, Q. So the number of onto functions will be number of elements in A, that is n, is 3. Number of elements in the set B is 2. So the number of onto functions formed will be 2 power n minus 2. That is 8 minus 2. 6 onto functions can be formed. One more example. If the set A is having 1, 2, 3, 4 elements and the set B is having PQ, you are making function from A to B. Number of elements in set A is 4. Number of elements in set B is 2. then the number of onto functions formed will be 2 power n. N is 4 minus 2. That is 16 minus 2. 14 onto functions can be formed. Similarly, if you take another formula under this only, like the number of onto functions that can be defined from set A to set B in different case, that also can be taken here. For example, if A I will take 1, 2, 3 and B I will take P, Q, as we did already. Here, number of elements in set A is 3, which is n. Number of elements in set B is 2. So, the number of onto functions we can count is 2 power n minus 2. That is 8 minus 2, 6. But if the same example I will change slightly. That means in set A, I will take elements 1, 2, 3, 4, which is natural. But in set B, I am not taking 2 elements, I am taking more than 2. I can take 3 elements, I can take 4 elements, I can take 5 elements. Any number of elements. Still, I can find number of onto functions from A to B. How can I do that? I have to take the number of ways or dividing number of elements of A set into number of elements in B set group, so that no group is empty. But remember, in such case, number of elements in set A should be greater than or equal to number of elements in set B. If you want to use this formula, I repeat again, I am giving you an example. The number of onto functions that can be defined from a set A, which is given here, onto a finite set B, which is given here, that will be equal to the number of ways of dividing number of elements in the set A into groups, into number of elements in set B, groups. We will take the things and we will divide it into groups. The number of ways we will see here. So how that is possible? You have to use combinations here. Dividing things into groups. Different combinations you have to use. And what is that? First of all, number of elements in set A is 4, which we are dividing into groups. The number of elements in set B is 3. So how can you divide it into groups? First, I will take number of elements in the set A, total 4 factorial. Then when I divide it into groups, because there are 3, I will take 1 factorial, 1 factorial, 2 factorial. Plus, another way is number of elements in A is 4 factorial. Because I am dividing it into groups, that is possible in 1 factorial, 2 factorial, 1 factorial ways. The other way is because the number of elements in set A is 4, I will take 4 factorial and I'll divide it into groups that will be in 2 factorial, 1 factorial, 1 factorial ways. So that means I will be getting 12 plus 12 plus 12, total 36 onto functions. The number of onto functions will be 36. This formula is slightly difficult. I will explain you what is the way. Why did I take 4 factorial by 1 factorial, 1 factorial into 2 factorial? What did I say? Total I have number of elements in the set A as 6. And number of elements in the set B I am dividing into groups. Is that clear? So let us discuss on the next page clearly. A is the set having 1, 2, 3, 4. B is the set having P, Q, R. First of all, total number of things I have 4 things, which I have to divide into groups. How many groups I will divide? Because n of B is 3, I will divide it into 3 groups. So in how many ways I can divide? What are the possible ways if I want to divide? Like I can take 1 and 2 under one group, 3 in another group, and 4 in another group. One way I'm telling you, one way. Or the other way, I can take only 1 as one group, 2 and 3 I can make as one group, and 4 as another group. Or the third way, this is the second way. Or the third way is I can keep 1 in one group, 2 in one group, and 3 and 4 in another group. So when I'm giving you only one way, but there are many possibilities that this group can rearrange in 2 factorial ways, this only in 1 factorial way, this only in 1 factorial. This group, second way, in 1 factorial, this group in 2 factorial, and the 4 in 1 factorial ways. Third way, the first group in 1 factorial way, the second group in 1 factorial way, the third group can arrange themselves in 2 factorial ways. So there are 3 ways possible like this. That is why total 4 things, 4 factorial, by the first way, 2 factorial, 1 factorial, 1 factorial. We will multiply. This we will learn in detail when we go to permutations and combinations lesson. The second way, 4 factorial total arrangements and 1 factorial first group, second group 2 factorial, third group 1 factorial. Then third way, total 4 letters, 4 factorial. First group 1 factorial, second group 1 factorial, third group 2 factorial. So 4 factorial means 4 into 3 into 2. Into 1 I need not write. 2 factorial is 2. So the same thing I have for all the 3. In all the 3 I can cancel 2. So I will have 12 plus 12 plus 12. That is 36 onto functions I can make. So this type of formula will be helpful if B has more than 2 elements, 3, 4, 5. But one thing you have to remember, number of elements in A should be greater than or equal to number of elements in B. If this doesn't happen, then you have to say 0 on 2 functions are formed. If number of elements in set A is less than number of elements in set B, then you will say no onto functions can be formed. No onto functions, 0 onto functions. This is how the shortcut method will be helpful here to count the onto functions. This you will better understand once you learn permutations and combinations. Under fourth one only, there is one more formula, that is being. Suppose you are making function from A to A only. Then you can find number of onto functions with the help of a formula. What is that? Sigma r equal to 1 to n minus 1 power n minus r into NCR into r power n. Again, this is combinations formula. Just you have to plug in and use. Coming to the fifth formula, f is the function from A to B. Suppose if number of elements in A is equal to number of elements in B, then the number of bijective functions that can be formed, you can write number of elements in A factorial. But if number of elements in A is not equal to number of elements in B, then 0 bijective functions are formed. Here also we will take one example. Like if A is 1, 2, 3 and B is P, Q. The number of elements in set A is 3. Number of elements in set B is 2. N of A is 3, N of B is 2. They are not equal. That means 0 bijective functions are formed. The same thing we will learn with few more examples. Suppose A is P, Q and B is 1, 2, 3. N of A is 2. N of B, number of elements in set B is 3. Again, they are not equal. So 0 bijective functions are formed. Coming to the next example. Suppose if A is 1, 2, 3 and B is P, Q, R. Number of elements in set A is 3. Number of elements in set B is 3. Both are equal, same. Then the number of bijective functions will be 3 factorial. That is 3 into 2 into 1. That is 6 bijective functions can be formed. This is how this formula will be helpful. Now, I am going to draw a few Venn diagrams to make you familiar about sets using diagrams. Always universal set you will denote by a rectangular box. In that you will draw set A and set B like this. They are not disjoint. That's why I'm joining them. If you want to shade A union B, first I will shade the circle A and then with the same design I'm going to shade circle B also. Similarly, I will take the universal set with a rectangle, and in that I will draw set A and set B. Now if I want to draw A intersection B, first I will draw set A with this color. Now I have to draw set B. So set B I will draw with a different design and a different color. So the part where you can see both colors and both designs, this part, this represent A intersection B. For the next diagram, again I will take rectangle as universal set, and in this I will draw the set A, set B with circles. Now I have to draw A minus B. That means when I draw a circle, I will not take B circle at all. B circle I'm not drawing at all. This is A minus B. In the same way, another diagram, this is universal set. In that I am taking set A and set B. Now I have to draw B minus A. So when I draw B set, I will not touch the A set at all. I will remove the A circle completely. I will not shade at all. So this is B minus A. If you see A minus B and B minus A, easily when you take A minus B diagram, B minus A diagram, and take union of it, and then you will take union of A intersection B diagram also, then total you will get A union B diagram. You can observe carefully and notice that. The next is, again I will represent the rectangle with universal set. This time I am drawing only A set because I want to draw A complement. That means leaving A, I will not shade A at all. Don't shade A. Except A, you shade the entire thing. That is A complement. Then next is again one more rectangle representing universal set. This time I will take set A and set B. I want to draw symmetric difference of A and B. That means I will take A minus B and B minus A and take union of it. So first A minus B means don't circle, don't shade the circle B. B minus A means don't shade the circle A. Take both of them. That is symmetric difference of A and B. Coming to the next diagram, Venn diagram. This time the rectangle is universal set, of course. I'm drawing disjoint sets. The sets are disjoint. They are completely apart. This is A set, this is B set. So when I take disjoint sets, I have to draw like this. So after seeing this diagram, when you take A and A complement diagram, if you take intersection, nothing is common, empty set. But if you take A diagram and A complement diagram, if you take union of it, you will get the universal set. that you can observe. Okay, coming to the next point. If you have a rectangle as universal set, and in that you have three sets: set A, set B, set C. This I will name A, this B, and this C. Suppose if I want to shade only A. Only A means I will shade only A circle. I will not touch the B circle. I will not touch the C circle. So this region is only A. Suppose if I want to shade only B, then I will shade only B circle. I will not touch the A circle or C circle. So this region is only B. And suppose if I want to shade only C, then I will shade only C circle. I will not touch the A circle and B circle. This is only C. Now, based on this, you can write down a few important things. If you want number of elements in only A, what you have to do? You will take number of elements only in A. Intersection B complement, intersection C complement. That means you will take number of elements in A intersection B union C complement. That means you will take number of elements in A minus number of elements in A intersection B union C. Why did I write this? Because in sets, you have learned one important formula. What is that important formula? In sets, which is with this. N of A intersection B dash, B complement. It is N of A minus N of A intersection B. This formula I have used here. So based on that, I got this. Okay, so this further, if I want to continue, I can write it as number of elements in set A minus number of elements in A intersection B plus number of elements in A intersection C minus number of elements in A intersection B intersection C. I am using the formula for A intersection B. This formula will be number of elements in only A. Or I can further modify it as number of elements in set A minus number of elements in A intersection B minus number of elements in A intersection C plus number of elements in A intersection B intersection C. The same thing I can use to find number of elements only in B. If you follow the pattern, it will be number of elements in B minus number of elements in B intersection C minus number of elements in A intersection B plus number of elements in A intersection B intersection C. Follow the same pattern. Number of elements in only C will be number of elements in C minus number of elements in C intersection A minus number of elements in B intersection C plus number of elements in A intersection B intersection C. The same pattern is followed. Okay, coming to the seventh shortcut formula. If number of elements in set A is n, then you can find how many binary operations can be formed. Sometimes you will be asked about binary operations also. The binary operations on the set A, that will be n power n square. That is the formula. You can see one example to understand better. Suppose the set A is there with 1, 2, 3 elements. Then the number of binary relations, if you want to find binary operations on A, you know that number of elements in set A is 3. So the number of binary operations will be 3 power 3 square. That is 3 power 9. The next is eighth one. Actually, whenever you find domain or range, there is a particular pattern. First, when you want to find the domain, the first thing is, if you have a function only with numerator, no denominator, then the domain or the axis can be any number from negative infinity to positive infinity. But if the function has numerator and denominator also, then you have to see whenever denominator is 0, the function will be undefined. So that particular value of x should not be taken. Suppose in denominator, suppose the denominator is x minus 3. If it becomes 0, the function will become undefined. So x should not be equal to 3. X can be any number except 3. The domain can be any number except 3. Like that you can take. Similarly, if the function is having square root, then whatever the number is under the square root, that number has to be greater than or equal to 0. Suppose if under the square root you have x minus 4, that has to be greater than or equal to 0, or x has to be greater than or equal to 4. That will be the domain. Okay, the next case, fourth one. If the function is having square root in the denominator, then whatever is under the square root, that can be just greater than 0, not equal to 0. Suppose if I have x minus 7 under the square root, it has to be greater than 0, or x has to be greater than 7. That will be the domain of the function. Similarly, if the function is log, like log of some number or something, so whatever this number is, that has to be greater than 0. For instance, if the number is x plus 8, that has to be greater than 0. So the domain is x greater than negative 8 minus 8. That will be the domain. This is for log. So there are restrictions for each type of function. If you take exponential function a power x, there is no restriction. The x or whatever is the power that can be any number from minus infinity to plus infinity. No restriction at all. But still, if you want shortcut methods, I will give some functions and I will give the domain of the functions in the form of formula. Like the first one, square root of a square minus x square. The domain will be minus a to a. If it is 1 by square root of a square minus x square, it will be between minus a and a. Next, if the function is square root of x square minus a square, the domain will be minus infinity to a union a to infinity. If the function is 1 by square root of x square minus a square, then the domain is minus infinity, between minus infinity and a union between a and infinity. Then if you have square root of x minus a into b minus x, remember a is less than b, then the domain is from a to b. But if the function is 1 by square root of x minus a into b minus x, where a is less than b, then the domain will be in between a and b. Similarly, there are some more cases where I will give you the function and the domain as formulas. If you can memorize this, if you can by heart it, it will be easy, time saving. If the function is square root of x minus a into x minus b, where a is less than b, then the domain will be from minus infinity to a union b to infinity. But if the function is 1 by square root of x minus a into x minus b, where a is less than b, the domain will be between minus infinity and a union between b and infinity. It is the difference of only closed brackets and open brackets. That is only the matter. Then, next kind of function. If you have square root of x minus a by x minus b, where a is less than b, then the domain will be from minus infinity to a union b to, from b to infinity I can't say, I have to say between b and infinity. The next is if the function is square root of x minus a by x minus b. This, if it is interchanged, that means x minus b will come up and a will come down. That is a different issue. We are not taking that case. We are not taking interchanging case. So what we will do is, we will take the same case, square root of x minus a by x minus b, when a is less than b. Then I can write the domain as minus infinity to b. I can't say minus infinity to b. I have to say between minus infinity and b. Union from a to infinity. Like this also can be taken. Still there are many cases, so I will write it on the next page. I'll write functions column and domain column separately so that you can match. So continuing from the previous one, I'll just start the numbering again. Like if I take the first function as square root of x minus a by b minus x, where a is less than b, then the domain will be, you can include a, but you can't include b. This is the interval. Next kind of function, if you have square root of x minus a by b minus x, here a is greater than b, then in the interval, don't include b, but you can include a. The third kind of function is log of a square minus x square. So the domain will be between minus a and a. And the next one is log of x square minus a square. The domain will be between minus infinity and a, union between a and infinity. Then the fifth function is log of x minus a into b minus x. Here a is less than b. In such case, the domain will be just between a and b. Again, because the place is not sufficient here, we will take some more functions and we will write the domain of such functions. So I'll number it as 6. Already I have taken x minus a into b minus x. So this time I will take log of x minus a into x minus b, where a is less than b. The domain will be between minus infinity to a, union between b to infinity, b and infinity. Next kind of some function, seventh one is tan mx. So you can take all real numbers except odd multiples of pi by 2m. The next function is cot mx. In the domain, you can take all real numbers except multiples of pi by m. The ninth function is, I can write sine, cos and all, but for all these, there is no restriction. Like for sine x, cos x, no restriction at all. That means you can take all real numbers for domain, for sine and cosine. No restriction. Okay, till now I told different methods for finding domain. One method is, I told you about numerator, denominator. I told you about square root. I told you about log. The same method can be used for range also. Whenever you take domain, you will see that the equation will be y equal to in terms of x. And you will use the methods which I told you. But if you want to find the range, change the equation. Make some arrangements such that you will get x equal to equation in terms of y. And then you can tell about y in the same way as you told about x, like numerator, denominator, log, square root, powers, and all. The same thing you can tell for y also. This you will understand if I give you one example. So let me give you one example. Like I have a function y equal to 3x minus 5 by 2x plus 1. One example I'll tell you. I want to tell about the domain, keep the equation like this only. Because it is having denominator, so 2x plus 1, if it is 0, the function will become undefined. That means if x is minus 1 by 2, the function will become undefined. So don't take minus 1 by 2. Take all real numbers, but don't take minus 1 by 2. That is the domain. For the same function, if you want to tell the range, change the function. Instead of y equal to, you must have x equal to. So for that, what I will do? Just arrangement. 2xy plus y equal to 3x minus 1. 2xy minus 3x equal to minus y minus 1. X common, 2y minus 3 equal to minus y minus 1. X equal to minus y minus 1 by 2y minus 3. Once you get x equal to, see the denominator. If the denominator is 0, that means x will be undefined. If y equal to 3 by 2, the function will be undefined. X will be undefined. So don't take y equal to 3 by 2. The range, that is y, it can be any real number but not 3 by 2. So the same method for finding the domain and range for the same function. Only thing is, in domain you will have, to find domain, you will have y equal to, and to find range you will have x equal to. That is the difference. But the same thing for other ways also. But there is shortcut formula for some functions to find the range. If you can memorize, you can do that. For example, if the function is square root of x square minus a square minus x square, sorry. If the function is square root of a square minus x square, the range will be from 0 to a. Similarly, if the function is a cos x plus b sin x plus c, the range will be from c minus square root of a square plus b square to c plus square root of a square plus b square. Okay, this is all about domain and range for few functions. There are some special functions whose domain and range you have to find in long way. But I want to tell some more shortcut formulas for you. One is, if f of x is a function, any function, then what I want to tell is f of x plus f of minus x, already I told you, it will be even function. And then f of x minus f of minus x will be odd function. That is to be remembered. Similarly, there is another shortcut formula. That is, if f of x is ax plus b by cx plus d, where d I will put as minus a. I'll make a small change to make it more easier. Instead of plus d, I will write it as minus a. D I'm writing as minus a. Then f circle f of x will be x only. You can directly say that. In place of d, if I write minus a, you can use the shortcut formula. Next, there are some special functions. Like if there is a function absolute value of x plus c by x plus c, then its domain of the function, directly you can write all real numbers except c. And you can also write the range easily. It will be -1 and 1, only these two. Similarly, if you are given many functions, for instance, if you are given two functions, then the domain of f plus g function can be written as domain of the function f intersection domain of the function g. Similarly, the domain of fg function can be written as domain of the function f intersection domain of the function g. Domain of the function f by g can be written as domain of the function f intersection domain of the function g. But remember, g of x should not be equal to 0. That is the condition, because g of x is in the denominator. Then domain of square root of f function will be domain of the function f and intersection the set which has x equal to f of x greater than or equal to 0. Actually, these two are just confusing for you. So I feel that instead of going for shortcut method, it is better you can go for long method here for division and square root. But still, if you want to learn the shortcut method, I will write no problem. Domain of the function f by g will be domain of the function f intersection domain of the function g. Remember, you have to take the set of x such that g of x should not be equal to 0. X equal to g of x should not be equal to 0. That is very important. Similarly, when you take domain of square root of f function, you have to take domain of the function f intersection the set which has x equal to f of x greater than or equal to 0. While doing problems, while giving you examples, you can understand better about these last two. That is why I said these last two examples are little bit difficult. These last two shortcut methods. So all of you learn the synopsis and these shortcut formulas by the time you come to the next class, so that in next class we will start doing multiple choice questions from this chapter. See you in the next class.